7 years ago, I published a video showing you how you could use an Xbox Kinect as a 3D scanner. The software I covered in that video is no longer available, so in this, my 3D scanning mini-series, I thought it was time for an update. Today I'll be showing you how you can use a 14-year-old Xbox Kinect, which you can buy today for the price of a cinema ticket, as a 3D scanner. So, let's take a look. Depending on your age and how into video games you are, you may be wondering what exactly an Xbox Kinect is. Following the success of the 2006 games console, the Nintendo Wii, which featured accelerometers in the controllers, allowing you to play games by physically moving them around in your hands, Microsoft wanted to get in on the physical gaming space. In 2010, they launched the Xbox 360 Kinect, a revolutionary and one-of-a-kind device in the gaming sector. It's a bar of sensors that you place above or below your TV facing out into the room. It can then detect and track multiple people, meaning that you were the controller. You could drive, dance or play sports, all with the Kinect just tracking your body. A later version that we'll be discussing more in a bit was even able to detect a player's heart rate, meaning that games could then react based on how frightened the player was or how difficult they were finding a workout. Unfortunately, the Kinect was released ahead of its time, before the days of VR gaming when people became more happy to get off their sofas to play a video game, and after 2 short generations the Kinect was discontinued. Well, sort of. They stopped producing it for the purpose of gaming, but people had quickly realised after its release that the Xbox Kinect featured an impressive range of sensors at a compelling price point, making it a useful tool for things like machine vision and other practical purposes such as 3D scanning. In 2012, Microsoft released Kinect for Windows, specifically designed to be plugged directly into a Windows computer for use as a tool. They later released adapters for both versions of the Kinect, so even the ones originally released for use with Xbox could then be plugged into a computer. So what exactly do you need to 3D scan with an Xbox Kinect? Well, there are 3 bits of hardware that you'll potentially need, and then there's the software. The Kinect was originally released for use with the Xbox 360, and it has this nice curved edge design. We'll refer to this version as the Kinect V1. There are many different types of technology which can be used for depth perception in 3D scanning. I lightly touched on this in the series intro episode when discussing a brief history of 3D scanning, and I'm going to go into them more later in the series. The Kinect V1 uses structured light technology. This means it projects a pattern in near-infrared light out in front of it, and then an infrared sensor detects how the light that's reflected back is distorted and calculates the distance and shape of the object based on that. This allows for a good level of accuracy. In 2014, Microsoft released a new iteration for use with the Xbox One, confusingly called the Kinect One. To keep things clearer, this is often referred to as the Kinect V2, and that's what we'll do today. The Kinect V2 features a bolder and more boxy design, and they did include a thread in the base which can be useful for easily attaching it to a tripod. Microsoft completely changed tactics for the Kinect V2, switching from structured light technology to time of flight for sensing depth. Time of flight scanning sends pulses of laser or LED light and measures the time it takes between projecting the light and it returning to the Kinect, then calculating the distance to the object based on the length of time and the speed of light. This change made complete sense with the Kinect's use case as a gaming controller. Time of flight can be much quicker than structured light scanning, meaning less input lag on the game. It can also be more suitable for scanning slightly larger objects, people, at slightly further distances where superfine accuracy isn't required. Unfortunately, it moves in the opposite direction for 3D scanning, where structured light scanning can yield much higher degrees of accuracy than time of flight. Whilst the Kinect was discontinued as a gaming peripheral after the V2, Microsoft released the Azure 6 years later in 2020. Unlike its older siblings though, the Azure was released specifically as a developer tool for use in AI and machine vision projects. Whilst you can use the Azure for 3D scanning, at its price point it's in direct competition with other dedicated 3D scanners that I'll be looking at later on in this series, and it isn't so relevant to this video on how to 3D scan with an Xbox Kinect. So back to the hardware you require. You're obviously going to need an Xbox Kinect, and you can use either a V1 or a V2, but if you don't already have one, make sure you watch to the end of this video before you decide which version you want to buy. If the one that you've got or are getting isn't branded as for Windows, that's absolutely fine, but you're also going to need an adapter. There are adapters available for both versions. The V1 adapter is basically a mains plug and a USB plug for your computer, and then there's a female USB port halfway down the cable to plug your Kinect V1 into. The adapter for the V2 features a breakout block with 3 ports, one to feed in mains power, one for a USB cable to your computer, and one to plug in the Kinect V2. I'll pop links to both of these adapters in the video description. The final piece of hardware you need is a compatible computer running Windows. Whilst Mac was previously compatible, it's less supported now, and I'll talk about that more in a minute. Before we look into the software options, the first thing you'll want to do is install the driver. Now in theory, this should happen automatically when you plug the scanner in, but because it's such an old driver, this is frequently reported as not working from the get-go. The fix for this will depend on which version of the Kinect you're using. If you're using a Kinect V1, you'll want to download and install the Kinect for Windows SDK V1.8, which I'll link to in the video description. If you want some more tools to play around with it and for other applications other than 3D scanning, whilst you're at it and once you've installed the SDK, you'll also want to download and install the Kinect for Windows Developer Toolkit, which I'll also link to in the description. However, this toolkit isn't required for 3D scanning, so I won't be covering it in this video, but if enough people comment here saying that they'd like me to cover it, maybe I'll release a video or two in the future. If you're using a Kinect V2, you'll want to download and install Kinect for Windows Runtime 2.0, and again, I'll pop a link in the description. And if that doesn't get it working, open up Device Manager with the Kinect plugged in. Expand the Kinect Sensor Devices section, right-click on WDF Kinect Sensor Interface and select Update Driver. Then search automatically for drivers. These solutions have always got me up and running, but playing with software, drivers and hardware from over a decade ago is always a funny game. So if you are still having problems, there is a wealth of information available online with a number of different fixes that you can try. Once you do have the drivers installed and the computer is recognizing that the Kinect is plugged in, the next thing to do is to download and install the software that you'll use for 3D scanning. In my previous video on this 7 years ago, I was using a piece of software called Kscan. Unfortunately, that was discontinued and it's not been officially available for years. I'm sure if you searched around you would find places that you could download it, but that's probably going to be on an installer archive site where I personally wouldn't recommend that you download and install any software based on security concerns. The most popular option to rise up since Kscan is Scanect by Structure.io, which allows Kinect 3D scanning on both Windows and Mac. Unfortunately, this popular go-to in this space has been taken down, as the developers replace it with their new Structure Capture iOS app. Their new focus is a mix of their own bespoke 3D scanning hardware as well as an iOS app, neither of which work with the Xbox Kinect. Luckily, there are still a couple of options actively available directly from the developers which allow you to easily use a Kinect as a 3D scanner. Microsoft has made it nice and easy with their own software 3D Scan, which you can download via the Microsoft Store. For some reason, it doesn't come up when you search for it in the Microsoft Store app, but if you go to the 3D Scan page on the Microsoft website, it then will load it up in the Microsoft Store app for you, so I'll link to that in the description. The other option is an independently developed program called Reconstruct Me, which you can download directly from their website called reconstructme.net. The main similarity between these two platforms is that, unlike Scanect, they are only available on Windows. Whilst there is still a number of ways that you can connect a Kinect to your Mac for use as a depth sensor in your own machine vision projects, as far as I'm aware, there is no platform currently available that will allow you to natively use an Xbox Kinect as a 3D scanner on a Mac. If you do know of one though, please do let us know in the comments. Now, the biggest difference between Reconstruct Me and 3D Scan is that Reconstruct Me only works with the Kinect V1, whereas Microsoft's own 3D Scan only works with the Kinect V2. This is because the V1 and the V2 work in such drastically different ways, as I mentioned earlier, and each of these pieces of software was developed for managing a very specific type of 3D scanner. 3D Scan is the simplest way to use a Kinect as a 3D scanner, but it's also the most basic of these two software options. We'll start out with 3D Scan and then we'll take a look at Reconstruct Me. When I covered 3D scanning with an Xbox Kinect 7 years ago, I 3D scanned an Iron Man helmet which I'd recently printed. I still have the same helmet from way back then, but it does have a fairly simple geometry which isn't really the best test for 3D scanning. My new go-to scanning test is Sea Gasket, the gas mask wearing horse, lovingly named by you guys just before this series began, and a big thank you for not calling him Horsey McHorseface. So let's scan this with the Kinect V2 using Microsoft 3D Scan. I should note that whilst I am giving you an overview of these workflows here, this is not a tutorial video. Once this 3D scanning mini-series is over, I will be publishing a number of deep dive tutorials showing you how to use the various software and hardware that I cover in this series, and that will include episodes showing you how to use and make the most out of Reconstruct Me and Microsoft's 3D Scan with an Xbox Kinect, so make sure you stick around to see those. The first thing you'll want to do is get your scanner, your scanning subject, and your scanning environment set up. Technically, you can have your Kinect in a static position fitted to a tripod, and then have your object on a rotating turntable in front of it. This is what I did in my old video, but this also isn't ideal when scanning with a Kinect. The problem here is that even if the Kinect isn't actively scanning objects in the background, it's going to use the geometry of anything it can actually see to track its relative position, as the Kinect doesn't have an IMU, so it can't feel how it is being moved. So whilst it would see the objects on the turntable moving, it would also see objects in the background being static, and then it would get confused about how the Kinect itself was moving. If you are going to use a turntable, try to maximise the distance between the turntable and anything behind it to minimise the additional geometry that it's going to be able to see, and try to use a blank textureless background with minimal tracking points. What's a better method is to have your object that you're scanning in a fixed position, which gives you access to every angle, and then move the Kinect around the object. You also want to have your object as evenly illuminated as possible from every angle, whilst making sure that the light isn't so bright that it's going to overpower the cameras and the sensors, and equally making sure that the light isn't too dark. So now let's delve into Microsoft's 3D Scan with the Kinect V2. Here we have a view of what the Kinect is currently seeing. It makes everything black and white except for the area that you've selected for scanning. This white box is your frame and allows you to crop the area that you're scanning, which you can then adjust by either dragging the corners or dragging the sliders on the left here. The other slider here is depth. Now the Kinect V2 struggles to scan anything closer than around 50 centimeters, so already that throws out the option to scan any particularly small items with it. Being at such a distance with a wide lens, it would kind of be like trying to get a close-up of a drummer on stage at a gig from the very back of the venue using your phone's camera on one-time zoom. So you can determine the closest distance that it will scan by just placing the Kinect 50 centimeters or more away from the object. With the depth slider, you can adjust the furthest distance that it will scan, so you could set it to ignore and not scan anything in the background. Here, you can rotate the camera view if you've got your Kinect orientated sideways. To start the scan, you just click the red scan button here, and that will then be replaced with a stop button which you can press to end the scan. You want the scanner to be facing the thing that you're trying to scan, and in the correct distance range when you click start, so it knows that that's the thing that it should be scanning and tracking. If you can't hold the scanner in position whilst you click start, you can set a timer. This will give you 5 or 10 seconds once you've clicked start before it begins scanning, and then you can choose whether to either end the scan automatically after a set amount of time, or end it manually, which will require you to click the stop button once again. Once you've started scanning, you'll get a view of the rough scan points it's captured in the bottom right. This isn't the final point cloud, so don't worry too much if it looks messy and incorrect, as it'll clean this up a bit when it processes the scan. If the border of this view turns red, it means that it's lost its position in tracking, so return the scanner to a position that you know it's already successfully scanned so it can try to relocate its recognised track points. If you can't get it to rectify this, you may need to just start the scan again. It doesn't seem to be fantastic at doing this. Previously, in K-Scan, it worked by having you capture a series of still frames, and you needed to set it to either automatically take a scan every X amount of seconds, or you needed to manually click for every scan frame that you wanted to capture. Whilst 3D Scan is a lot more basic in features than K-Scan was, it does at least have live scan, so there's no need to do that. It will just constantly scan until you hit stop, although a pause would be really nice. Once you end your scan, it will then generate the point cloud and then the mesh, and it will then prompt you to either save your file as a 3MF or to open it in 3D Builder. 3D Builder was another Windows program for viewing and light editing of 3D models. Unfortunately, whilst 3D Builder is still listed on Microsoft's store, it can no longer be downloaded and doesn't feature a download button, at least in the UK and on Windows 11. It may elsewhere and in earlier versions of Windows. If you don't have 3D Builder installed and you click that option, it'll allow you to select another program that you do have installed, so you could then have your scan open directly in a slicer like Prusa Slicer or Bamboo Studio. As you can see though, scans exported from 3D Scan are often incomplete and not yet suitable for 3D printing, requiring some cleanup and some fixing. So before importing them into a slicer or whatever you actually want to do with this model, bring it into something that you can fix it up with first. Hey guys, I just wanted to quickly mention that if you like my videos and you'd like to support me to keep making more in the future, you can hit the join button below my videos to become a channel member. Not only would you then be supporting me, which I'd be incredibly grateful for, but you'd also get channel member benefits, including early access to my videos, exclusive access to the 3D Rev Discord community, and a members discount at 3drevolutionstore.com, where you'll find 3D printing and maker-themed clothing and accessories. Right, back to the scans. There are a lot of options that you can use for this, but a good free one is Mesh Mixer by Autodesk. In here, you can select and delete anything that the scan picked up that you don't want. You can then close cracks in the mesh, and rather than it being open and hollow, you can close any holes from unscanned areas such as the base and make it a solid object. So after cleanup, this is what we got scanning C-Gasket with the Kinect V2 in 3D Scan, and I'm not gonna lie, it's not great. By comparison, this is the result from scanning C-Gasket in the same setting with the Kinect V1 in Reconstruct Me. However, whilst the V1 did manage to capture more details and finer features with this model, C-Gasket is still quite a small object for the Kinect to scan. Anything smaller and it can really struggle to identify and track it. Whilst trying to scan something smaller than C-Gasket, like this Star-Lord bobblehead, both Kinects and both programs struggle to track or scan it. The Kinect V2 does seem to manage tracking smaller objects a little better, but because of the reduced detail in the actual scan, a lot of the time, even after several rotations, it claims not enough data has been captured, and even when you can complete a scan, you can end up with just a simplistic blob. So now that we've seen that the V1 is capable of capturing more detail than the V2, and we've established that a slightly larger object would be better, let's scan something else, this time using the Kinect V1 in Reconstruct Me. This time we're going to scan this mid-sized statue, which should be a good test to see how much detail it can capture with this rough, rocky, bark-like texture. Reconstruct Me has a pretty different user interface to 3D Scan. As I mentioned earlier, this video isn't a tutorial, but I'll give you the gist of it for now, and then I'll cover it in more depth in a future video. This first tab, Volume, gives a representation of your scanner and what it can see. The black bar is the scanner, and the blue cube represents the area not that it can see, but the area or volume that it will be scanning. When you're on this tab and the Kinect is plugged in, it'll give you a rough indication of what it's seeing, and this will help you position the Kinect or the object appropriately. You can also adjust the size and position of this box to scan your subject, but avoid as much of its surroundings as possible. Under Handling, much like in 3D Scan, you can set a delayed start and a scan duration, but allowing for much more specific time choice here. Finally, under Device, you can choose between prioritizing speed or quality when processing the scan. Right, let's hit Start. Now we get a full screen view showing us what the scanner has detected so far. Sometimes it doesn't show us certain areas that it has scanned until it's completed the scan, but it gives you a good indication. We don't get a live camera view like we do with the V2 in 3D Scan, but you can easily see what parts of the model you're looking at to orientate the scanner. Once the scan is complete, you can preview your scan here, and then you can save it as a PLY, OBJ, OFF, or STL. Whilst it may capture more detail, much like with the Kinect V2 and 3D Scan, scans from the V1 via Reconstruct Me will likely need cleaning up, so you'll want to import this into something like Mesh Mixer to delete unwanted mesh and close any holes in the model from unscanned areas. And this is what we got. It looks like there might be a couple of areas that I didn't properly cover, like this patch on the head, but for the most part it is all there and it is recognisably the same statue. It doesn't seem to have picked out quite as much detail in this bark texture as I was hoping, but there is some evidence of it there still. Let's get it printed and see how the detail translates into a print. As I said, there is a couple of areas that I didn't fully cover when I was scanning with the Kinect, so we've got this hole on the top of the head, for example. But other than that, it looks very similar to the original statue. I can see all of the features there. I can see the hands, the eyes, the nose, the mouth. They're all just less pronounced than they are in the original statue. In the same way, I can see evidence of the bark-like texture, and it's more evident on the back. But again, that is less pronounced than it is on the real thing. Though if you were to do a longer scan, you would be able to pick out more detail in this texture. Either way, I think this is impressive for what's effectively a 14-year-old toy designed for gaming. The Xbox Kinect was originally designed for gaming. Specifically, it was designed for tracking the human body. It was designed for humans. We've just scanned a mini humanoid, but let's see how well it deals with a real person. Let's scan me. Now, Reconstruct Me actually has a dedicated selfie mode for scanning yourself, where it suggests that you sit on a rotating office chair with the scanner at face height, and it will automatically stop the scan after you complete one full rotation. Whilst this may make the process a little easier, I don't feel this will produce the best result, as it will only be using a single rotation from a single perspective, so there's going to be a lot of guesswork for the top of your head and under your chin that it just won't have seen. So for now, I won't be using that, and I'm going to do this manually. Today I'm doing this on my own, and there's no easy way of 3D scanning a full human body on your own without at least moving your legs, which then ruins the scan. So for today, I'm just going to scan a bust of myself. To do this, I've set the Kinect on a tripod, and then standing in front of it and trying to keep my face as still as possible, carefully and slowly turning around on the spot. And then I'll try to angle myself to show every angle of my head without changing the relative positions of any bits that it scans, so the relative position of my head to my shoulders, for example. Well, that came out surprisingly well. Obviously, this isn't a high quality model by any stretch of the imagination, but that is a 3D model and it's recognisably me. Well, like I said, that went better than expected. Whilst it may not be the best scan in the world, I think it's pretty impressive that a 14-year-old gaming controller managed to generate this 3D model of me with a 90-second scan. I'm actually particularly impressed with the level of detail in the folds of the t-shirt that you can see mostly on the back here, but on the whole, I think it came out okay. What do you think? You think there's a likeness? We'll be revisiting 3D scanning people with a range of 3D scanning technologies, including Kinect, later in this series. We'll also have an extra pair of hands for that to allow for better quality and maybe even full body scans. Make sure you subscribe so you don't miss that. And that's 3D scanning with an Xbox Kinect in 2024. With the Kinect V1 capturing more detail than the Kinect V2 and regularly selling on eBay for less than £10, it's easily the cheapest way of 3D scanning if you want some dedicated hardware to 3D scan with. This technology was really impressive to have so readily available 7 years ago, but as we've seen today, especially with these limited software options, it's not the most capable of 3D scanning platforms. And as we'll see later on in this series, depending on your use case, there are a number of other options for you to use which may provide you with better results even if you're on a limited or non-existent budget. So this is definitely good fun to play around with, especially if you've already got one lying around or you just wanted to drop £10 on something to tinker with. But as a serious 3D scanning platform that yields usable results, especially in 3D printing, I feel this has very much fallen behind the competition. Especially as not only are the results not fantastic, but to use it, as well as needing to be tethered to a computer, which, granted, other platforms we'll be covering in this series also need, but that computer needs to be running Windows, and the Kinect needs access to mains power, so having access to even a powerful laptop isn't necessarily going to help you. That said, make sure you stick around to the end of the series when I'm going to be pitching the Xbox Kinect V1 against 4 other 3D scanning technologies, scanning a range of very different objects to see which platform is best for 3D scanning in different situations, then seeing how each of the results look when 3D printed. Next episode, we'll be looking into the art of photogrammetry, a term which was coined in the 1800s but has its roots even earlier. Photogrammetry is a form of 3D scanning which is used professionally around the world today, and is something that pretty much everyone watching this video can go out and try without needing to spend a penny, so make sure you subscribe and tune in for that next week. I hope you found this video interesting, and if you did, please do hit that like button, and don't forget to subscribe and hit the bell button so you don't miss the rest of this series and my future 3D printing and megatech videos and tutorials. Just as a reminder, if you really like this video and you'd like to support me and get yourself some goodies, you can hit the join button to become a channel member. As always, thanks very much everyone, until next time, happy printing. If you've just discovered this series, why not check out the series intro where I cover a brief history of 3D scanning. If I've already released the next episode by the time you watch this, I'll pop that here, but until then, it'll be another video where you can learn something new or have some fun. Thanks very much everyone, and until next time, happy printing.